Here's the client. In this demo, we'll create a translation application. The app uses Amazon Translate to translate a text into a different language, German. After translating the text, the app saves the result into a DynamoDB table. The app uses the table before translating to make sure that the same text was not translated before. If it was, it'll use the save value, and if it wasn't, it translates the text and saves it into the database. So we'll expose the translation component asynchronously using Amazon API Gateway. And then we'll provide a way to invoke the translation component by sending events to an SQS queue using Amazon EventBridge pipes. Amazon Simple Queue. So to recap, we'll build step function state machine to translate the text. We'll integrate it with API Gateway to expose the functionality. We'll invoke the state machine from an SQS queue using EventBridge pipes. And then I'll also create a SAM template to deploy the application towards the end. Let's get started. I'm in North Virginia region, US East 1. In the search bar, let's type in CloudFormation. And in CloudFormation, let's click on Create Stack. Choose an existing template. We're going to upload a template file. In the description, I'll also add the details for you to upload this YAML file. So it's workshop-template.yaml. Let's go ahead and click Next. Let's give it a stack name. I'm naming it Serverless Event-Driven Demo. Leave everything default, no parameters. Let's scroll down. Leave everything else default. Let's acknowledge. Click Next. Leave everything default. And submit. Create in progress. Should only take a minute. It's not a complex stack. Okay, creation complete. Now let's build AWS step function state machine. So in the search bar, let's type in step functions. I'm opening this in a new tab. And there's our state machine created from the stack. So let's highlight that state machine and click on Edit. Okay, here you can see our design console. You can see the actions on the left, the most popular. You can see our start, and that's our past state, and then the end. So we want to click on past state, and we're going to delete that. Okay, I'm going to dismiss that. Close that out. We want to click on JSON ATA, which is recommended. in the search bar, let's type in translate text. Drag it over. Okay, we're going to configure translate SDK call parameters. And translate is going to translate German and English. So highlight that JSON and delete it. And I'm going to paste in these arguments. It's also in the workshop demo. Click Save. Okay, so that was successfully updated. Okay, let's go ahead and execute. Click Execute. And we want to start our execution. So we already hard-coded the API parameters, so we can use a empty JSON string. So we're typing in the open and close bracket, and we're going to start the execution. Okay, so here we're looking at the details, and if we scroll down, we can check the results. So this is our graph view, and click on Translate Text, Input Output, and you can see the state output. So it's in German. Hello and welcome to our workshop. So it translated the English text to German. Now let's go back to State Machine, and we want to pass the input value to the API parameters. So let's delete the argument. Okay, and I'm pasting in this new argument, and we're going to save it. Okay, we're going to test this workflow. Okay, we're going to paste in this JSON. Right, so the text is hello and welcome to the workshop. Let's start the execution. Scroll down, the graph view, click on Translate Text, and you can see the state input and output. Okay, hello and welcome to the workshop, and then that's the output, the translation. So now we're going to set a variable with the original text. Okay, so click on Variables. Okay, and we're going to paste that in. So that's the original. We're going to save that. And the variables allow other services to call the state, i.e. DynamoDB. So that was successfully updated. Let's close that out. And we can later reference it from other states. So let's go ahead and test the workflow. Let's paste that in. Hello, welcome to the workshop. Start the execution. Okay, we're in the Details tab. Let's scroll down. And Graph View, click on Translate Text. You can see the input. If we click on Variables, you can see our assigned variables. So that's the original text. Okay, the original state. If the state changes, it can always revert back to the original text variable. Now we want to store it in DynamoDB using step functions. from step functions. So in the search bar, we want DynamoDB put item and drag that underneath translate text. Okay, you can see our query language is JSON ATA or ATA. Okay, we want to configure the put item call. So click on arguments and output, and then we want to save the translation data into the DynamoDB table. So let's copy that argument, delete that, and we're pasting in this new argument. So the original text and then the translation text. Configure the output of the put item task. So let's scroll down to output, and we're going to paste in this JSON. So it passes the state to the next workflow, the state output. Okay, let's save it. And we want to test it, so let's go ahead and run this workflow. Click on execute. Okay, let's go ahead and paste in. Okay, text, hello and welcome to the workshop. So that executed. Scroll down. So there's our DynamoDB put item. Let's check input output, and you can see the state input and output. It's translating it into German. Now we're going to go into DynamoDB and actually check the table. So type in DynamoDB in the search bar, open in a new tab. And in the dashboard on the left, click Explore Items, and you can see we have one table. Click on Translation Table, and the items return, you can see the original text and then the translated text. So it passed it to the DynamoDB table. Now we're going to edit the step functions with the choice state. Okay, so click on Code. So this is the code for our step functions. From row 41 all the way to 1, let's go ahead and delete that. And we're going to paste in this new JSON. Slide the graph over. And then you can see, so we want to get the translated text from DynamoDB, right? The first graph view. And then we want to check if it's tested. Translation, this is our choice state. That's the choice. No data output. Translate text. It's the default pass if it's true. It'll translate it. Okay, and then the translated text will pass it to DynamoDB in the table. And then map the data to output. Right, that's the put item in the DynamoDB table. And then if it's true, it'll end. And the query language is JSON ATA. So let's save it. And we're going to run this workflow. So click on execute. We're going to start the execution. Let's paste this command in. Hello, welcome to the workshop. Okay, let's scroll down and you can see our graph view, map data to output. Click on that. Okay, and you can see this is our state input, which we walk through, and then this is our output. So it's translating it to German for us. Now we want to integrate it with the API gateway. So API gateway can integrate with various AWS services directly, such as Lambda function to perform custom code, an elastic load balancer to balance the load between different targets, Amazon DynamoDB to read and write from a table, a step function state machine, and so much more. So you choose an API integration type according to the types of integration endpoint you work with and how you want data to pass to and from the integration endpoint. For Lambda function, you can have the Lambda proxy integration or the Lambda custom integration. For an HTTP endpoint, you can have the HTTP proxy integration or the HTTP custom integration. For an AWS service action, you have the AWS integration of the non-proxy type only. If you don't have any special custom logic to perform while integrating with other AWS services, chances are that it might be unnecessary. So direct integration provides you a more value and less operational overhead while eliminating the need to implement your own integration code. An example scenario where a direct integration is a better fit is ingesting clickstream data through a REST API. So in this scenario of the demo, there's no custom logic that we need to perform prior to invoking our state machine, and therefore it is a good fit for a direct integration. Okay, so that was our architecture. And I'm clicking on outputs. You can see we have our ARN that we're going to use. So in the search bar, type in API. We're going to open API Gateway in a new tab. We're going to scroll down to REST API. Click Build. The details, new API. We're going to give it a name. I'm going to name it translation-API. Scroll down. Click Create API. Now we're going to create resources. Click Create Resource. We're going to give it a name. Translate. Click Create Resource. Next, we're going to create the method. Click Create Method. And method details, just click on Post. Highlight AWS Service. Region, we're in US East 1. AWS Service. Let's scroll down. Step functions. Subdomain will leave blank. HTTP method is post. Use action name. And the name is start sync execution. Execution role. Now we're going to go back into CloudFormation and we're going to copy the state machine ARN. So copy that and let's paste it in the execution role. So that's our serverless event-driven demo. Scroll down. Create method. Close that sidebar, close out our successfully, and we're going to create an integration mapping. So let's scroll down, click on integration request, edit, okay, leave AWS service highlighted, USD Swan, services step functions, method is post, use action name, scroll down, and let's go under mapping templates, add a mapping template, and we're just going to type in what we see, application/JSON as the content type. Let's scroll down to the template body. We're going to paste this in from the workshop. Okay, now that's our state machine ARN. So in between the speech marks, go ahead and remove that. And that's where you'll paste in your state machine ARN. So let's go back to CloudFormation and grab that. Okay, that's our translation state machine ARN. So copy that. And let's paste that in. Okay, I'm going to remove that or take it up to row 3. There we go. Just click save. Okay, slide that. So let's test it. So click on test. And in the request body, we're going to paste in our test command that we've been using. So click test to run it. And there's the output. You can see that's the latency in milliseconds and status 200, which is successful. And in the response body, you can see there's our translate in German. So now that that looks good, let's go ahead and deploy the API. And we'll create a new stage. For stage name, entering prod, and deploy it. Close that out. So note the invoke URL that was created for us. Okay, we're going to test this in the terminal. I'm opening up my terminal. Apologies that it's small, but just for the demo. So I'm pasting this in, this curl command. And we want to go up and replace and enter our API URL. So delete. And we want to paste it in between those brackets. So copy your invoke URL. Paste that in, run it. And that's our output. Translated English to German. So let's clear that out. And our API URL is correct. So now we want to transform the API response. So let's click on Post under Resources. Click on Integration Response. Edit. Scroll down to Mapping Templates. And in the body, we're going to paste this in. Save it. So the body response is going to be different. And let's go ahead and test this new template. Let's test it. So paste this in. Let's click test, and then here's the output. Latency status 200, and it translated it into German in the response body. So now we're gonna, we know that the mapping template is working, and it only returned the translated text. So now that that's working, let's deploy that API. Okay, select prod. And deploy. Close that out. So let's test it in the terminal. Paste in our same command. Enter the invoke URL. Or replace it, remember. Copy that. Paste it, and let's run it. Okay, and that's the body of the updated template. So that's also working. So clear that out. Exit my terminal. Amazon EventBridge pipes connect sources to targets. Pipes are intended for point-to-point integrations between supported sources and targets, with support for events, transformations, and enrichment. It reduces the need for specialized knowledge and reduces the amount of integration code you need to write when developing event-driven architectures, fostering consistency across your company's applications. So to set up a pipe, you choose the source, add optional filtering, define optional enrichment, and choose the target for event data. So the event source begins sending events to the pipe, and the pipe processes the event before sending it to the target. If you've configured a filter, the pipe evaluates the event and only sends it to the target if it matches that filter. You only charge for those events that match the filter. If you've configured an enrichment, the pipe performs that enrichment on the event before sending it to the target. If the events are batched, the enrichment maintains the ordering of the events in the batch. So we'll configure an Amazon SQS queue as our source of the event, set up the EventBridge pipe, and connect it to the AWS step function state machine as our target. So in the search bar, let's go ahead and type in EventBridge. Opening this also in the new tab. So on the left panel, let's click on pipes. And that's our overview, source, filtering, enrichment. Click on create pipe, and you can see our graphical display, the steps. So we have source highlighted. Oh, forgot to give it a name. So under name, just going to name it Serverless Event Driven Pipe. Okay, and under source details, we're going to select SQS queue. Queue name is highlighted. Event Driven Demo Queue. You want to select where it says queue. So the filtering, for now we're going to skip the filtering, but we'll come back to it. So just press next, and we're also going to skip enrichment. Next. Target service, step functions, state machine is our translation state machine. And target input. So this is the event payload. So we're going to paste that in, the body and then the text. And in the transformers section, and then that's the output. Okay, so let's create the pipe. Okay, so that was created. So you can see our source and our target. SQSQ is the source, step function. So now that that's running, let's go ahead and invoke it using pipe. So in the search, SQS, opening this in a new tab. Okay, so we're gonna publish a SQS message. So click on our demo and we're gonna send a message. So in the message body, let's paste that in. Hello developers, welcome to the workshop. And let's send that. Okay, so it was already sent. Now let's confirm that that message was delivered. So at State Machines, back in Step Functions tab, let's click on our translation state machine, click on View, and you can see these are executions. So far there's a total of 10, but we want to select our latest. So highlight that, click on View Details, and if we scroll down there, that's our graph view. Okay, remember this was the choice state. So that's the state input, and then scroll down to our output. So that's the translated output. So SQS is successfully working. Now we want to create the EventBridge pipe and we want to add a filter. So the filter is just going to allow what we want it to pass and not allow what we don't want to pass. So click on filter, filtering, AWS events is the source, and make sure prefix matching under the drop down is selected. So that's how it's going to filter. We're going to paste in that JSON body length. Yep, so it routes any language that starts with the prefix EN. Okay, we're going to skip over enrichment. Click next. Target. Leave everything there. And we want to update this pipe. So the filter is added, source, SQSQ, filtering, and then that's our target. Step functions, state machine. So let's go ahead and test the updated pipe with the filter. So let's go back to SQS, and you can clear the content. Just hit the clear button. Let's add to the message body. Paste in with the prefix EN-US, so that's sent. And let's confirm the delivery. So this is what we added in the filter for it to allow. So let's view the details. Previously we had 10 executions, now 11. So that was successful. Let's choose the latest. View the details. Let's scroll down. Okay. Map data to output. So that's our state input. And let's scroll down to output. Status code 200. And that's our translated text in the output. So that updated filter worked correctly. But we're also going to verify that to see what it catches. So currently we have 11 executions. So close that out, clear the content. We're in SQS. And in the message body, let's paste in. So this is a Spanish prefix, ES-MX. We're going to send this to see if the filter catches it or doesn't allow it to pass to the step function state machine. So you can see we still have 11 executions, so look like that's working. Refresh it. Yep, so that's working. Now let's go ahead and verify again. We're going to clear that context. And let's see if our previous filter accepts the in-US prefix. So we ran that. Let's refresh it. Now we have 12 executions. So the filter is working perfectly. So let's go to map data to output. Let's scroll down to output. You can end the video here if you like. I ran into an area trying to create the SAM template, but I'll clean up resources using the CLI towards the end. Okay, so here I am compressing the template docs that's needed to upload into the AWS SAM CLI. So let's type in Cloud Shell. And again, this is for viewing purposes. So I wouldn't necessarily follow these steps, but in the workshop, you can see the steps also. So just double checking in USD1 and actions. Gonna upload that zip file. Yeah, and I had an error from a previously saved SAM template that I tried to create. So I'm just going through the process, typing in that command, unzip it, select A for all, and then trying to build out the SAM, and then it was showed up as an invoke GitHub error. So now I'm just going to clean up and delete the resources through AWS SAM, but you can also do it in the console. So here we're typing in AWS CloudFormation -- stack to get info of our stack, clearing that out. Next, typing in AWS CloudFormation delete -stack -- stack -name, and then whatever you name your CloudFormation stack, type that in here. It's serverless -event driven -demo. So let's run that, and we can confirm the deletion in the console. So let's refresh. Okay, so that's working. Deletion is in progress. Okay, now let's go ahead and delete the REST API. So I want to get the API gateway. So AWS API gateway get -rest -APIs, and that's our ID. So typing in AWS API gateway delete -rest API. -rest API -ID, and then copy your ID And we're going to paste that in. Let's run that. And let's check in the console. So CloudFormation is still in progress. API Gateway, let's click on APIs. Let's refresh. Okay, so that's deleted. Okay, we're going to delete the EventBridge pipes. AWS pipes, list dash pipes. Okay, so that's it. Serverless event-driven pipe. So typing in AWS pipes, delete dash pipe dash name, and use your pipe name, serverless dash event driven dash pipe as my name. Run that. Okay, see it stopped and deleted, but let's check the console. Okay, let's refresh. Okay, and that's deleted. Okay, close that out. Let's check CloudFormation. Okay, so the stack is now deleted as well. Thanks for watching this workshop. Have a good one.